As we go into topic 3 of module 6, we're getting into what is called logarithmic functions. And we'll graph logarithmic functions, which are very similar to what we've done already. We're going to talk about common logarithms, equivalent functions, and solving certain logarithmic equations. But before we start, we want to find out what in fact is a log. Well, what we just had in the previous chapter, or section I should say, was this function right here, which you may recall was the inverse of this one. Y equals 3 to the x power. And if we switch that around, we got x equals 3 to the y power. That was the inverse. Okay, let's see if we can read this a little bit. Now, x is the exponent to which we must raise, let me take a step back here because it's not x, it's y. This y is the exponent to which we must raise 3 to get x. So the exponent to which we raise 3 to get x. And I have it written down here. The exponent to which we must raise 3 to get x. Now we're going to replace those words, the exponent to which we must raise, these words we're going to replace with a new symbol. And that symbol is log, or logarithmic. Logarithm. Log is the short way of saying it. So the log of 3, log base 3 of x. So we call that log base 3 of x. So hopefully you're able to take these notes down and how it ties in to our previous lesson. And as we start to go through some examples, hopefully that will be the repetition, the drill, to develop mastery of this. So what does log mean? It's the exponent to which we must raise something. And the log of base 3 of x is how we read it. And that will have some value out here. We're going to put some value in there for x. This is like a general form. All right, let's go on. Now, one of the methods I strongly suggest when you look at an example like this, log base 2 of 128, that we convert it into our base, which is 2, to some exponent that will equal the answer, which is 128. So remember, log refers to the exponent of that base that will equal 128. So having this little helper might be very useful. Now, I happen to know that 2 to the 7th power is 128. So the answer to this would be your exponent is 7. All right, let's do this one here. So again, this little tool might be helpful. Your base is 4. We're wondering what exponent do you raise the base 4 so that it equals 1. Well, this one's a little tricky. And if you remember, anything to the 0 power is 1. So the answer for this example is 0. So what exponent of the base 4 will equal 1? And it would be 0. Anything to the 0 power is 1. All right, this one's a little tricky too, because it's 3, which is our base, to what exponent would equal 1 over 27. Now, we did this in a previous lesson too. Now we know 3 to the 3rd power would be 27. And what form of exponent do we need in order to get the reciprocal of 27? And if you recall, it was -3. So the answer is 3 to the -3 equals 1 over 27. We did one of those in our T-charts. Now, letter D is a little interesting because we'll see this later in lessons, and it's sort of interesting here. Here our exponent is this, and we have this here. So whenever this number and this number are the same, again, we're not going over it completely yet, but I will a little later on. Whenever this number and this number are the same, the answer is just this, 93. So this is sort of a definition. When you see this arrangement, the answer is what's here, 93. And I'll explain that a little bit more in a later lesson. Now, in example E, they're asking us to graph this. Well, we are given y is equal to the function of x, which would be y is equal to the function of x, and there the 4 would be our base. But now we're interested in the log. So when we do log, it's the inverse of it. So we switch the y and the x around, and we get this value to graph. And we did that in an earlier lesson. And the graph of this then, if you recall, it goes through 1 here, and then it goes through 1, 2, 3, 4 there, and then it goes up to 16 out here, and it looks like that. And that is the graph of this particular logarithm. Now remember, we did this one where this one was a 1 here and a 4 there and a 16 way up there, and this was the inverse of that. But this one here is this graph right there. And again, take notes, so if you see something like it, you know it's this. Now I just put this here for comparison. So in fact, let me just take that off of there so you're not confused. Okay, this is this graph here. Now, we're not using a calculator for this specifically in our course, but if you were to put that in one of these free online graphing calculators, this one, because of the +2, is shifted up a little bit higher. The other one, you recall, was down here. This one is shifted up by 2. So instead of going through this point, it goes through this point. And that's all you really need to know to recognize the shape of the graph. And remember that generally speaking, logs are the inverse function of what we saw up there. Now in example 3, we're asked to rewrite each as an equivalent exponential equation. Right now they're in the log form. Well, remember our little helper, base to an exponent equals an answer. So we can start right here. Our base is 6. Our base to an exponent, which will be x, equals our answer 11. Okay, our base z to an exponent -4 equals 9. Now again, they're just showing you the relationship between this exponential form and the logarithmic form based on that statement. The new symbol, which is a log, to replace the words, the exponent to which we must raise, let's say 3, to get x in that original example we gave you. So here our base is going to be n. We're going to raise it to the m power to get p. Now keep in mind, as you put your answers in MATLAB, you don't put a little box here. You just use the exponent tool to put these in. Alright, without raising it, let's see what we can do here. Now we want to rewrite each, these are in exponential form, we want to write them as logarithmic equations. So we're going to go from this form into the logarithmic form. So we're going to use log, there's our base 4, of the answer 64 is equal to the exponent y. Alright, give e a try. And you're working on a pattern. So log base a of 9 is -2. And for letter F, log base x of z equals y. Okay, now we have some equations where we're asked to solve for x. So again, putting it into that exponential form may be useful. We have our base 4, our exponent is a -2, and that's going to equal our answer x. So what is 4 to the -2 power? Well, we did that one earlier too. We just bring it 1 over 4 to the second, which is 1 over 16. So x is 1 over 16. Alright, in example 2, here we have base a to the second power is equal to 36. Now, what we have to do here is go to our tool bag, and we haven't had this one yet, but if we change this 32 to something to the second power, 36 to the second power is, or something to the second power is 2. There we go. So now we have a to the second power. Since our exponents are now the same, our bases have to equal each other. So a here is equal to 6. So this tool was, when we converted it from logarithms to exponential equations, a to the second equals 36. We converted 36 to 6 to the second. Our exponents are now the same, so our bases must equal each other. Now, here's a case where background is needed, and we have the log of 10,000 equals y, and there is no base. Well, this is our common log that we use often in mathematics, and that's common log base 10. If it's base 10, we don't write it usually. Okay? So setting this up is going to be base 10 to what exponent when we have the answer is 10,000. Now what we need to do here to solve this is put 10,000 into some form of 10 to what power? And the answer is the fourth power. So now in this example our bases are the same, so our exponents must equal each other. So our answer there is 4. Okay, we have one more to do, and I think we can leave this here. We have base 7 to the d power, that equals 1. So what did we say is 1 to any power? That's tricky here. So we have to get 1 into the form of 7 here. So let me write it over here. It'd be 7 to the d power, and I'm going to just give this away, 7 to the 0 power. Because what is anything to the 0 power? It's 1. So this 1 I can make into 7 to the 0 power. Now that my exponents equal each other, d equals 0. And that's the answer. Okay, we've had some examples here. We need some practice, and I have some material that we'll be doing as practice.